Hello everybody and welcome to our first lesson in Unit 4, Congruent Triangles. Today's lesson is about triangle sum properties, and the objective for the lesson is we will be able to classify triangles by their sides and angles, find interior and exterior angle measures in triangles, and use properties of isosceles and equilateral triangles. First of all, let's review some crucial vocabulary. A triangle is a polygon formed by segments joining three non-collinear points. Phew, that was a lot of vocabulary. Non-collinear points, remember from when we had that word in the previous unit, that just means that we have 3 points that are not on the same line. Because think about it, if those 3 points are on the same line, then all we get is a line. But as soon as one of the points is a little bit off, and it doesn't even have to be as much as I'm showing here, and you're joining these 3 points, here goes your triangle. We can classify triangles 2 different ways: by the angle names. An acute triangle has 3 acute angles. So let me draw you an example. And when you draw it on your notes, make sure that all 3 angles are really acute. An obtuse triangle has 1 obtuse angle. I'll give you an example. Something like this would be considered an obtuse triangle. And a right triangle has 1 right angle. An equiangular triangle, think about the name. Equi means equal, means the same. An equiangular triangle has 3 congruent angles. I'm going to draw one that looks equiangular. And to support that, we can mark our 3 angles and give them a congruent mark. These 3 angles are congruent. This is an equiangular triangle. The other way to classify triangles is by their side names. An equilateral triangle, similarly to the equiangular one, has 3 congruent sides this time. Equilateral means the same sides. And if I draw something that's supposed to be an equilateral triangle, I also better make those congruent marks for those 3 sides, indicating that those 3 sides have the same length, that they are congruent. An isosceles triangle has at least 2 congruent sides. At least 2 congruent sides. It could be 3, but it has to be at least 2. So therefore, something that would be isosceles and still not equilateral may look like this. These 2 sides are congruent. I'm using congruent marks, and I'm also using different ones than I used before, because these sides are most likely not congruent to the ones of the previous triangle. And last but not least, we have a scalene triangle. Scalene triangles have no congruent sides. And we show this by giving each side a different congruency mark. All right, then let's continue and name the parts, the crucial parts of our triangle. A triangle has 3 vertices. This point down here is a vertex. Triangles have 3 vertices. A triangle also has 3 sides. This, for example, is a side. And a triangle has 3 interior angles. Interior angles, and you'll see in a minute why I'm saying this. This is an interior angle. But if I take this side here in the bottom and I extend it like this, then I can create something which is also an angle, and this is called an exterior angle. You remember interior and exterior from our angle relationships in the previous chapter. And sometimes we need those exterior angles as well. So let's talk about special parts of a right and of an isosceles triangle. Right triangles have a right angle. And if you look at that right angle, and if you put another line here, then this angle looks almost like an arrow pointing towards this side. And the side that this arrow is pointing at is the hypotenuse. The hypotenuse is always opposite of the right angle, and it's the longest side of our right triangle. The other 2 sides also have names. We call them legs. So this is a leg, and this is a leg. Let's look at isosceles triangles. Isosceles triangles, when we look at them like that, and we have the 2 sides that are congruent, showing this by our marks, those 2 sides we also call legs, similarly to our right triangle. And then if we have it up like that and the legs to the 2 sides, the side that's at the bottom is called the base. Those 3 angles of our isosceles triangle have names as well. The 2 angles, and these 2 angles happen to be congruent every time, we call them base angles. And they are always congruent. And then we have one angle on the top, and this angle carries the name vertex angle. Discussing the parts of an isosceles triangle leads us to the first theorem that we will talk about in today's lesson, the base angles theorem. And the base angles theorem basically says if 2 sides of a triangle are congruent, let me show this by these 2 congruency marks, then 2 angles also have to be congruent. Those, in this case, are the base angles. 2 sides of a triangle are congruent if and only if, this is a biconditional statement, if and only if 2 angles are congruent the base angles. Look at the example on the right. We can use this theorem to find out stuff. Here we're supposed to solve for x. We see that two sides are congruent, and then we have the two angles, the two base angles. If we were to take our paper and turn it sideways 90 degrees, you see that the segment AC is the base, and those are the two base angles, and they are congruent. In other words, we're saying that 2x has to be equal to 70. Well, if 2x is equal to 70, dividing by 2 on both sides, x is equal to 35. And that's that. There's also a corollary to the base angle theorem. Well, what's a corollary? Corollary essentially means an extension. And this corollary to the base angle theorem says an equilateral triangle. Equilateral means that all three sides are congruent, also has three angles that are all congruent. Equilateral triangles are, therefore, you remember the vocabulary from the previous page, equiangular triangles. Our example on the right says solve for x and y, and we are given the information that all three angles in this triangle are 60 degrees. In other words, they are congruent. That means the sides also have to be congruent. So then x plus 6 is equal to 8. Let's do the math. If x plus 6 is equal to 8, subtracting 6, we get x is equal to 2. And if 4y is also supposed to be equal to 8, well then 4y is equal to 8 divided by 4. Y is also equal to 2. That would be how we use the corollary to the base angles theorem to find out values if we have to. So much for this, and now go ahead and watch the second part of this tutorial.